Okay, so Henry Martin, is, you all know Henry, but at any rate, he's from Knust, department, a lecturer in the Department of Physics, and coordinates Mathematical and Computational Physics Unit. He's actually been to Rome Sapienza, so he probably is missing Italian pizza quite a bit. But his research focuses on digital twin approaches to real-world problems through multi-scale, multi-physics modeling, machine learning, and statistical analysis. So it really spans many areas: water systems, aerodynamics, renewable energy, and materials science. So he's going to talk about the state of quantum science and technology in Ghana, addressing the quantum divide and ensuring inclusiveness for all through the SDGs. So, Henry. You get that.
All right, thank you very much, Joe. And I would like to first of all thank the organizers for making this possible, and as well thank all the MCP units and all the international collaborators that made this possible as well. So I'm going to try my best. What I'm supposed to do is to tell a story, but as academic as well, we always give presentations, so I'll try to combine the two. The only thing is that I'm not sure the 30 minutes is enough because there's a lot going on, but I'll try my best. All right, so I'm Henry Martin, just as Joe said, and I'm from KNUST with the Mathematical and Computational Physics Unit, and I'm here to deliver the state of quantum science and technology to address the quantum divide and then promote the inclusiveness. Okay, so quantum basically we have known as a pivotal course in physics programs and in most of the specialized programs in mathematics, as well as of chemistry, computer science, and engineering have been taking some of these courses. And in quantum mechanics, we have been taught certain concepts like what we know as the many-body problems. And these many-body problems have been solved approximately using some kind of techniques. And these techniques basically are in the form of Hartree-Fock's density functional theory and so on and so forth. But more of it now is looking at some other concept, which is the superposition and then entanglement and others. This then has led to the quantum science and technology. With then we have the quantum computing, which looked at the development of algorithms, and then we look at software and then hardware. We have the quantum communication, we then look at the ensuring of network channels through encryptions and all of that. We have quantum sensing and meteorology that then looks at the measurement and controls. We have the quantum material and so on and so forth. I believe yesterday, most of you heard a lot about that. Now, in the global landscape, there has been a lot that is going on in terms of the improvement and in terms of development. And we have seen across the continent that in Europe and in Asia, they have been, first of all, been able to build quantum research centers. A typical one which we already know is the center in Canada, where they have Parameter Institute, Waterloo, and so on and so forth. They have also been able to come up with startup or companies that are bringing in development in these regards. And we have so many of them, like IBM, we have Unitary Fund, we have IQM, and so on and so forth. They have also been able, continentally and nationwide, come out with national strategies that they intend to employ, that in this number of years, this is what they intend to achieve going forth. But the story in terms of Africa is far, far different from that of the global world. And so in Africa, what are we looking at now? For some time now, I think just about a month ago, the African continent community met in South Africa and decided to come together and try to build this kind of alliance, which is called the African Quantum Alliance, for short, Africa. And their idea is to get everyone in Africa together so that they will be able to realize how to push forth the quantum development in Africa. Again, in our brothers in the diaspora, has also been able to form what we call as the African Quantum Consortium, which is a very vibrant group, and they are trying to push for the advocacy of development of quantum in Africa. Notwithstanding these two groups that have been able to push these frontiers for Africa to realize its fate, South Africa, on the other hand, has done so well. As we speak, I mean, in the past 15 years, they've had several conferences, they've had several breakthroughs. They have a couple of centers, a couple of quantum centers. They have also been able to come up with their quantum science and technology strategy. And they are working in quantum computing, they're working in quantum optics, and so on and so forth. Our other friends in Tunisia, they also have quantum centers. They've been able to come together as a people, as a network, and they are also working in quantum computing and so on and so forth. Morocco, on the other hand, don't have a center yet. They are doing some research, which is in the quantum key distribution. They're looking at some kind of quantum optics as well. And Egypt, they have a bit of research ongoing in quantum computing and quantum key distribution, but they are yet to start up some master's program in this regards. Now, the big question I believe we are all waiting for is Ghana. What is the state of Ghana? Where have we gone to, and where do we find our feet in now? Now, before I go to Ghana, I would like to just say something briefly to clear the air, that most of the African countries, or most of us here, are really into the classical simulation of quantum systems, where we are using some machines to now determine, like I said earlier on, in terms of the Hartree-Fock, DFT, and so on and so forth. Now, this we do in using the CHPC in South Africa, which you can see the map there, green, and then the slash red and blue are the countries that are involved in using these CHPC resources. And Ghana, as you see there, is the only West African country that is involved in this. But again, like I said, this is in the classical simulation for quantum systems. Now, even though we are part of it, we see that we are having about 33% of the programs that are using these resources. With the 33% of programs, you can see on the underhand side that we are having more than 50% usage across all this. And so it means that Ghana in itself is doing a lot of work when it comes to this classical simulation of quantum systems. And for this nodes, they have about 100 nodes. You can see at the top there that is at every time t, it is fully used. Apart from that peaks that drops, which are due to maintenance and all of that. And so this actually gives some kind of a queuing in terms of the job that we use. Now, Ghana in itself has about 16 traditional universities in the country. We have about 10 private technical universities and about 24 chartered private universities. Among these, we are having 6 main universities that are involved in some activities, both in the classical simulations and that of the quantum simulations. Now, I would like to start with the University of Ghana. And the University of Ghana, at the Maths Department, we have a group doing something in quantum gravity. And then at the Physics Department, they're also looking at the classical simulation of quantum systems. Now, in the University of Development Studies and that of CKT Kandam in Applied Technology, they are also looking at the same thing in terms of the classical simulation of these quantum systems. When we come to University of Energy and Natural Resources, the Computer Science Department, they have a group there looking at quantum machine learning to understand the stock exchange, that is the finance systems. I'll go deeper into those opportunities for us to understand them now. Now, in UCC, the physics department in 1992, Professor Alote here was able to establish them a photonics lab. And so they have been dealing with photonics since 1992. You can see that. They have started something all the way since 1992. And that is their LAFOC lab. And recently, I think in 2023, they had accreditation, which they established the the computational thinking lab. This is a lab with about 20 nodes of computers to do classical simulations again. And then you come to KNUST. In KNUST, we have several things ongoing there. So we have the engineering department, which in recent days, they have started some training in having to go into quantum telecommunication in terms of having to look at the encryption. We have the chemistry department that looks into computational chemistry. And it was set up in 2010, the quantum chemistry lab in 2010. And so they too have been doing something for quite a number of time here. The maths department, as of last year, started looking also into quantum algorithms that they will also use to understand our markets, that is our financial sectors here in Ghana. When we come to the physics department, I'd like to thank some people here, that is Robert. I think about 2023, they start to have some frontiers in light, and these have been able to generate some discussion, and they are about building the photonics lab in KNUST to look into characterization of materials. Then we have the mathematical and computational physics, which I'll dwell more in later to let you see how a pipeline can be developed. Now, this discussion that I have done here follows these decisions, which then you can see is an onion diagram, and then the first one tells you the level or the intensity into which we are undertaking some development in this area. The first one, which has to do with quantum experiment or quantum technology, is the main reason why you see that as the very least is that there's very limited experimental infrastructure, either to even start it up or to even maintain it going forward. And because of also the cost, and that brings me to the question I was asking the earlier presenter about how they are able to convince their government to do that. And so we as a country, we fall short very well in that area. But the second one, which has to do with the quantum computation, is an interest that is really booming up in these recent times, where we see most of our young men trying to go into quantum algorithm and trying to go into quantum machine learning. And that comes to the third one, which is the classical simulations, as I mentioned, is very, very intensive across the whole countries. In fact, if you look at the universities, as I mentioned, all the 6 universities, there is some form of classical simulation of quantum mechanics. And in terms of the theory, all physics programs, undergraduate levels, postgraduate program, does some physics. And in some mathematics department and chemistry and engineering, they do some kind of quantum mechanics. And so that is very wide across the nation. Now, so where do we stand, which is the reality check for us here? Do we have a center? Do we have a startup and all of that? And so with the brief thing I've said so far, we can say that, well, we don't have a national quantum strategy yet. But I believe, just as the presenter said, we have to get the people together. It's about the people. People are important, just as he said. And so bringing the people together, we may get there. Again, he said about the center, and that was why I was asking the question. So that before I come here, I think you know the answer to all the questions I'm asking here now. Okay? So, yes. So we don't have a center yet. We are already teaching quantum mechanics in all our programs. We don't have any setups yet or companies that are into. But yes, we can make them happen. And I'll show them as I move on. In terms of research, I've told you about 80% is into the classical simulations. There are a few doing some quantum algorithms and quantum machine learning. And so Ghana as a country and we as a people, this clearly shows the divide that we have with the global landscape, and then the divide that we have even among us in terms of our African country as well. And so we have to find a way as scientists to be able to solve a problem. As scientists, we look for a problem and then we solve the problem. That is what we are trained to do. And so the problem in having to solve is what we're looking at is as a big idea. And the big idea is for us to have a national quantum science and technology strategy. And we believe that this is a startup that most people are here discussing and trying to bring up something that this can be able to go on. And in doing that, we should be able to have cluster of center of excellence, which we call in the ARC-EDS. And so we think that this is possible, and this is possible through an educational and research pipeline that we ourselves have undergone through it as a means which I intend to show you using the Mathematical and Computational Physics Unit model. And so in showing that, I'll start to tell you that we started this in 2020 by having an accreditation from GTech with the physics department and KNUST. And the whole idea is for us to be able to build capacity. But as we all know, and across the whole of this week, there have been a lot of problems or a lot of challenges why this is not possible. And so what are the challenges? And we have the institutional, we have the student-owned challenge, we have the government and the industry. Of course, we as the institutes or the institutions, we face challenges as funding. The critical part is to fund. How do we fund everything we do in the university, including our resources? Lab is not, we are unable to fund the lab because of the equipment. We are able to fund the personnel, to get a lot of personnel to come and teach or to undertake research. And getting a lot of personnel then will mean that the workload in having to teach will have to reduce. But then we do not have that as well. And then on the student side, when you move back down to the senior high secondary school, it's rather unfortunately I'm not here this morning, but if you go to the senior secondary school and you ask the student, how many of you were even given the opportunity to come to KNUST to read physics? I tell you, you can get 1 out of 100. In fact, we have done that severally, and I'll show you. We moved to schools to have an outreach on that. And so that is also a problem. And in the other side as well, in most of our education levels, from the senior high school to the university undergraduate and then postgraduate, the transitions, how do we deal with this student? How do we get them to really do something? And then the funding for the student. Most of our students, and I believe everybody here is already aware, that most of our master students are working. And so the question now is if you are working, which is a full-time, and also undertaking your master's degree, do you have a lot of time to concentrate on research that can yield something out? These students have to work because they have to pay for their tuition fees, they have to look for their accommodation, and so on and so forth. And then the job market, which then is connected with the government and then the industry. The student then finish the physics course, maybe quantum, and then he gets employed where? Nowhere. Because there's no connection with the industry and the academia, so that we can be able to bring something out. But these are challenges. Scientists, again, we are supposed to solve challenges. And so that is where we start as our footstone in having to solve this challenge. And so how do we solve this challenge? First of all, we decided to move to the high schools to do an outreach program. We decided to do an open day program for the high schools even to visit us in the school, in our university, so that they see what we have, and then they can liken it to everything they do, and then appreciate what we are doing in the university. And so that is where we started in having to resolve the interest of the student. Then in how to do the transitions, we have a collaboration with some of the partners that we can have transitions. You finish your bachelor's, you can be able to take some online courses, you can be able to take some residence courses together with our partners, just that it brings you to the level of the graduate program that you wish to undertake. And this we're doing with Parameter Institutes. And then in terms of how do we go by the funding, or how do we go by the resources? This I remember in 2020 when the GTech committee came around to ask. They were like, are you sure you can run this program? How do you intend to fund the student? Because you want a full-time student. Then we were like, well, we have a model, and the model is for us to be able to have an exchange program. And this we started with University of L'Aquila. They gave us an MOU, we signed an MOU and all of that. And so that was presented. and we have exchange students with our partners. And in this time around, we have partners, they spend some time here, they spend some time there. And so sometimes we have an online, they teach them online, and so on and so forth. This is able to handle the challenges that we foresaw earlier. Then in having to link with the industry, the concept was that if you have students and you are training the student, sometimes it's difficult getting the funding from an international partner to do what you have to do that is pertaining to the social needs. But the only reason you can do that is when you get in touch with the companies and then you bring out the problem which the international partners have an idea about. And so I'll brief more about that when I get to the centers. Now, in doing all of this, we need to be able to set up conferences and workshops like this. Conferences and workshops that can be able to fund students from other regions, not just in Accra. I mean, if we have funding, students can come over from the north, from Kumasi, then they can be able to attend the funding, have discussions to see their reality. This we started way back in 2021 with One Quantum Ghana. I believe most of you have not heard of that. But One Quantum Ghana, we started this in 2021. And then in 2023, we went on to do the Quantum Akwaba. That was the first Quantum Akwaba we had, which was hybrid, in person and then online. And then we move on to some online other ones. There are other ones that the team is actually planning on. At the appropriate time, I believe most of you will be sent an invitation to join this conference. It's for us to harmonize and think about the country in moving forward with the country. Now, the vision for the big idea stands in terms of what we call the ARC-EDS, as I mentioned earlier. This is the team things that in having to undergo in the route of quantum science and technology, we may be able to segregate in terms of the onion diagram, where we saw the weaknesses. And so with the weaknesses, we can be able to segregate it into three parts. The three part having to deal with the mathematical, which we have to do some formulations for our algorithms. And the other part has to do with the computation, and the other part also has to do with what? The experimentation. These together, we're proposing the 3 centers for Ghana in the sense that, well, one center is already established, which is the AIMS Ghana. Their mandate is to come out with mathematical formulations, and that they are already doing well in that. And so what we are really left with is to look at our computational and look at our experimental. What are we doing or what can we do? And so we have the CALC Ghana, which is just Center for Applied Computation. That is the CALC Ghana, looking at all the simulation of these classical systems, including quantum system, algorithms, and so on and so forth. Where the EQUIT Ghana deals with the experimentation, the hands-ons. Because one, you cannot do computation without understanding the experiment. I mean, physicists, we always start from going to the lab. In our university, you do 2 years of lab work because you need to understand the fundamental physical phenomenon before you can do anything else. Other than that, it becomes like a black box. And so these are the 3 centers that we believe can be done. And the centers follows the pipeline which I described, or the model that I described that was centered on the MCP, because then there are challenges. We cannot sweep away the challenges that we have out in Ghana. We need to find a way to solve it. Others have done it. There is a plan to do it. So we can use the same way. We have the early identification of the students by going to the SHS, improve their interest. We have the integration of the NSS by having some transition plans and all of that. And then we have the funded MPhils and PhDs, so that with your exchange programs, I mean, there are so many international collaborations. Yesterday, you heard from Imperial College. They are willing to collaborate with all of us here in Ghana. This is a way for us to have exchange programs across. And then to have postdocs. Postdocs, in most of us, we know that in our governance settings, we cannot have employment from PhD straight away. Sometimes it takes a year, sometimes it takes 2 years before the government approves. I finished my PhD. Do you have to wait for the government? You need to be engaged in doing something. Some of us had the ability to travel outside the country to go and do something before employment comes. we can still employ the people here in our centers to do research work for the country, for the society, as postdocs. And that can be one of the opportunities. This can lead into what we have as the research base, the relevance of our research, what we can do. And that turns out to train more people for both the academia and that of what? The industry. Yearning to bring up the startups and the companies that the other global companies are already having. And that is the pipeline for that. And this can come out with any particular organogram where we can have the stakeholders in terms of CSR, GAEC, and all of that being part of the chain in the sense that we have the ARC-EDS with their 3 main centers and the universities. Already, every university in Ghana is undertaking some kind of research, either classical or quantum, but they may have to fall in certain aspects of these centers because you cannot rule away the university research out automatically because every researcher or every professor is employed to teach and also do research. It's part of it. And so as the centers, we have to be able to bring the people together. We have to be able to get everybody together to be under some specific center, to have to communicate, to know what they are doing. Then there's a plan, either biennial plan, 5 years plan for the country doing something which is related in this thing that we look at. One thing I always have to look at as well is it possible? I don't know why centers should be able to teach an undergraduate program or teach a master's program. As far as I know, in most of the centers are created for the research-based. And so, as I put a note there, centers are not supposed to be a taught master's program, but intensive research-based to see the development of the country. This can be discussions that can start in terms of having to solve our issues in quantum science and technology. And so then brings us to our strengths, our weakness, and all of that, and the main goals, which falls under this diagram here in terms of training more people, training more staffs, getting them to do something, becomes a cycle, coming back to the university, coming back to the industry, and then bringing up a lot of startup. Many people say that in other countries, the PhDs and all of that are going into companies because they have been able to raise a lot of people. And there are a lot of people who have a lot of knowledge to set up their own company and then be able to bring in improvement. And then the economy goes up. And so that is the cycle. And so if we are able to follow these forms, we'll be able to look at something. And we believe that, again, in 10 years, in 2035, that is to say in 10 years from now, we should be able to raise more people for the country. Because we started this in 2021, we had accreditation with just 2 students, 1 PhD. Now those 2 students are done, they are coming to do their PhD, the PhD will be completing soon. And so that is to say that is about 4 years now, next year is 5 years. And so to do a calculation and postulate in 10 years, if you take in more students, more than 2 or 5, you could have a lot of students, and this would be able to come back as generating economy for the country. Again, the speaker said, the relevance, the economic benefit that the country can have. And that was why I posed that initial question, for us to all to have our solution. Some may say, how do we get this relevance done? How do we prove to the government that classical simulation of quantum systems or quantum system is important? What can it do? There are so many aspects that are ongoing in some of the universities, as I mentioned, and also in KNUST. Quantum finance is there, as I've mentioned. Some people are already doing it. Drug design in chemistry, they have been doing that for some time now, for pharmacy and healthcare. We have water. We ourselves in the physics department, we're looking at some things in water. And I'll show you how this is being done. For the quantum finance, I can speak of what UNER is doing and what they are doing in KNUST in the maths department, trying to understand the stock exchange, trying to understand our financial markets, to come out with algorithms, which then based on quantum optimization, optimizing the chain that works. So that is one key simple thing that we as Ghanaians would be able to do using quantum to do. And the other ones are also there that in the future we can be able to look at. And when it comes to water, as I mentioned, in KNUST we're looking at this in terms of the digital twin, trying to monitor our water. Yesterday the lady spoke here about contamination, and it is general in Africa. We have contamination based on agrochemicals because of pesticides. We have contamination because of unused. I take my paracetamol, some is left, I just put it in the dustbin. It goes back to the gutters. Contamination is there. We have contamination based on liquid waste. We have contamination. And so the cycle of our water, there's contamination. Treating it is real time. How does quantum come into all of this? We have other ways. We're looking at quantum modeling of water in terms of using the treatment. We can develop crystal porous materials and having to look at the treatment. We can look at the quantum optimization. The whole water chain system can be optimized in using quantum. Quantum sensing and meteorology. One of our students will be visiting Germany in October in the research University of Bonn under the quantum meteorology. And these are some of the things that we can look. Yesterday, someone mentioned that, is that possible we can have a lab? Yes, that is one of the things we are also looking at. Developing an online lab so that you can be able to have all the optics that you can do. And it is also one of the things that we're having with the University of Bonn to develop some kind of techniques around that. And so this is with the chemistry, which they are looking into the drug and healthcare delivery. And all of this fit into the SDGs that we have been discussing all this while. We look at SDG 4, 8, 9, and so many of them. Partnership, healthcare, water, they all fit right into the discussion. I'll end my story here. I believe my time is far gone, but I think I have done some storytelling. And so, yes, we are not there yet, but we can get there. Together, if we can all come and sit at the table and discuss the way forward for quantum science and technology. The people, the government are one. Thank you very much.
It's on now. Thank you very much, Henry. That was really wonderful. Okay, so time for questions? Yeah. I imagine there'd be lots of questions.
All right, Prof, thank you so much. I think you've opened our eyes into so many areas that we weren't aware of it. But my problem goes with the teaching of physics. I think the fundamental is the basic level. Yes, teaching of it is a little bit difficult. And I think the teachers are not coming close to the student for better understanding. So fundamentally, we fear it before we go to secondary school. So by the time you reach secondary school, physics becomes a blow. When you see it, you run away out of it. So I think, yes, in as much as you are very good at that area, kindly do your best as well and be able to train the physics teachers too. They are so fearful. Yes. So that they can even come down to us for us to get the basis, for us to be able to love physics as other people are loving it. Thank you.
Yeah, thank you very much. I think this is connected to application as well. The physics need to be live. And I think we were discussing it last time. We say physics is everywhere, it's everything. And unfortunately, mostly we have, because of our settings, our physics has become more theoretical. And so we do not relate it. Like yesterday, we saw the light and all of that. That is the life of the physics. And so when the life of the physics is absent, then it becomes fearful. You see, so yes, we have to get it live. We have to let them see what the physics can do in every topic that they undertake. It's everyday life activity. That is physics.
Thank you very much. Yes, just to top up what you said, and also our lady also contributed. Like earlier I said so at the beginning, the challenge is how the course is presented with the students. It's the applications and all those things, friendly way. This is so that people, or the students will be happy with it. Like I give example in other universities that I witnessed, University of Texas in Austin when I was. You see, before the person, even the lecturers, they introduce you, tell the opportunities. The quantum, out of quantum, this water, I'll tell you that. So, yes, we don't look upon it at all. So when it comes to admission, it's full. You know here, when the person doesn't get engineering, of course, now improving, now it comes to physics. No. Do you see? So I think these are some of the things we have to look at. So all these things you are teaching or you are lecturing, let me ask you, how are you related to the industry?
Okay.
Do you see? What are you doing now? Yes, thank you.
All right. So like I mentioned, one of the critical things we are doing is in the water supply chain. We've had some discussions with the water companies, met the ministries, trying to, specifically, I mentioned about 3 ways that in the quantum we can be able to solve. I mentioned that even one of our students will be going to Germany in October. There are these areas that we can all venture into. So we have started in some of these areas. And as I mentioned, in the chemistry department, they have been doing this drug thing for some time now. So some of us are really involved with some of the industrial players. Again, maybe it's not quite opened, and I was believing that together as a people, when we start sitting down and discussing, this again can be made very open to the public, and so that also set up a platform for a conference like this. Because some of you were not privy to this, but because of this conference, today you are privy to it. And so if we can be able to have such conferences and workshops annually to be able to communicate some of this to the general public, I believe we can go a long way.
Right. Thank you very much, Prof, for the wonderful presentation, especially for coming down to our level and giving us hope in Africa that we can get there. Now, I have 2 questions for you. The first one is, how do we ensure that the youths who are in the non-formal sector or not in employment, education, and training can have the basic skill to be relevant in the second revolution of quantum science and technology? That's number 1. The second question, I would like to know some of the side effects of quantum science and technology on the environment, especially climate, and so on and so forth. Thank you very much.
Okay. The first one is more or less like the TVET. So how can TVET contribute? So as I mentioned, engineering is key. And one of the things we have in terms of quantum computing is the hardware. I mean, I always tell my students that some days back we used to have the disk ROM with a very big computer and all of that. Now all those big computers and the disk ROM, we can't find it anymore. It was a revolution. Things were being done, and all of that is hardware. So how do we now come together, again, coming together, the universities coming together with the technical universities, the vocational skills, and telling them that this is what we know, and this is what is ongoing in the global world. And this will transform in terms of the hardware for us to see some of these changes that some way back in the 1980s we saw, and now we have smartphones. And now we have these vocational skills people having to repair the smartphones. How did they learn? That is the question. And so if we can get them now to buy into this new change and together do something, I think they can also have their way through in terms of this whole quantum computing and all of that. Meteorology, medicine, and all of that. Like I said, optimization is one key thing in all of that, in all of this quantum thing we're discussing. Having to predict the weather is one thing that quantum computing also does. In South Africa, they have started some of this. Ghana, we can also. Other countries are doing some of these things, trying to use these systems. Energy, in the area of energy. I left energy out because I know panel discussion is coming, And I left IT out because I've seen the cybersecurity. Yes, they will discuss all of that during the panel. But there are so many things we can actually do in this area. Thank you.
All right, thank you. So I'll take it from the point of resourcing our higher education institutions to go into quantum technology. Now, we have research directorates in almost all of our higher education institutions, technical universities, traditional universities, private universities, and then quite recently, our colleges of education, nursing training, and all of that have committed at the recent GTech summer school to establishing research directorates in the various colleges. So, would you propose that there be established different centers to go into quantum technology in the high school, in the higher education institutions, or you'd say that, yes, let's resource these research directorates to go into it? And if you propose that, how do we go about it? How do we do that? How do we resource them? Thank you.
Thank you. So first of all, the research directorates are more or less like administrative or managerial roles, or let me say offices that oversee research in the institutions. The big question is, who will bring the money to do the work? And that is the thing. And so in the universities and the nursing that you are saying, it is the researchers themselves that has to go and look for the money to do their research, whilst the office, in terms of the research directorate, try to manage or have an administrative setting of all of this research for us not to have issues, so to speak. Now, setting up the center, as I showed in terms of the 3 centers that I was proposing, or we were proposing, we were looking at it in the sense that these centers, together with a structure, it could be any organogram, with stakeholders, will have meetings and will have plans and agendas for the country. And so if in 2025, there's a decision across the 3 centers that we're looking about water supply chain, how can those doing the mathematical formulation, that's AIMS, and GAC doing the computation and the experiment, come together to work to achieve this goal that they have all planned for? Okay, so, and they are the people who have to also look for the funding to help in doing that. Whilst the universities that are undertaking any research in this area are supporting that idea. So the research directorate do not bring the money, or the research directorate do not do the research. I don't know whether I've answered the question.
Okay, thank you very much. I think we have to move on to the round table, and I'm going to give this over to Sarah, but let's thank Henry again for a great talk.